All right, here we go on the 1.2 checkup practice problems. Now for these different graphs they're about to present to you, these are all new graphs to us here in Math 2. So I really think that we should go do this in a graphing calculator. So go open a new tab for desmos.com. Under Math Tools, choose Graphing Calculator, and let's put each of these functions in here. So the first one is the graph of y equals square root of x minus 3. There's our square root symbol, x minus 3, and here's our graph. So what I want to do is either print screen that image and save it to your computer or snip it. So I'm going to go right-click Save As and just call it Graph A. And then when we're back in the dock, I can just insert an image from my computer and I just go find that A graph. Now, if you're just writing this in your notebook, you're just going to sketch out this graph. The square root of x minus 3 is going to start at 1, 2, 3 to the right, and then it just goes whoosh off into the distance like this. So the question they're asking us about this graph is, use the graphing calculator to help you sketch a graph of the given function, and then state whether it is a one-to-one function. In each case, state how you know. So again, we're going to use the horizontal line test to see if it touches once. Boom, touches once. So yes, this graph is a one-to-one function because it only touches once on the horizontal line test. All right, let's go look at the next one. F of x is equal to 1 over x. Oh, look at this graph, how this comes out. So again, you can just be sketching this graph on your written paper or even sketching it with the draw tool. And I'm actually just going to copy and paste it into the all right. So this one is asking us again to do the horizontal line test and see if it's a one-to-one function. So if I draw a vertical line here, a horizontal line, I keep saying vertical. If I draw a horizontal line here, if I draw a horizontal line here, it's only touching once. If I try to draw it right here, this is called a horizontal asymptote. It's approaching 0 but never touching 0. So it's still not going to touch twice there. So what I'm going to say is yes, this is a one-to-one function because the horizontal line test only touches once. All right, let's go put this one into our Desmos calculator, x squared plus 3x minus 1. Remember that this little squared button is down here on this little calculator, x squared plus 3x minus 1. Okay, I got it. So now I'm going to go snip it and paste that image in. You guys can just be sketching this into yours. All right, let's do the horizontal line test. Ooh, and this one touches twice. So what does that mean? It is not one-to-one. It is many-to-one. When it touches once, it's a one-to-one function. When it touches twice, it's a many-to-one function. All right, f of x equals 6. I don't need to go to Desmos for this, right? We know this one. Maybe? I want you to picture a table where x is 1, y is 6, x is 2, y is 6, x is 3, y is 6. Y is always 6. So if I go out and up to 6, and out and up to 6, and back and up to 6, what's that line going to look like? It's going to be a horizontal line through 6. Okay, so how about this one? Is this a one-to-one function? If I draw the horizontal line test, oh my gosh, a horizontal line test is going to touch at infinite many places. So for this one, this is not a one-to-one function because a horizontal line test would touch infinite many times. So definitely not once. All right, we're all done with that one. Okay, now is this function one-to-one? Let's go look at a couple places here. If I draw the horizontal line test there, boom, touches twice. I can even specify where. I could say at y equals 1, at y equals 2, at y equals 3, it touches twice. Now it's asking, given some inputs, what are the outputs on this graph? So let's go take a look at the graph and see. All right, f of -1. So if I go back 1, they want to know what the function's value is at that time. So here's our area of interest. This is an open dot, so it's invalid. This closed dot is my value of f of -1. So f of -1 is equal to -1. How about f of 2? F of 2, go out 2, look up, the answer is 3. And if you're not quite sure, if you can't see that, you can go grab a little line here and just like see where you think that lands. F of 2 lands right around 3. All right, what is f of 0? Just 0. All right, here comes the big one. I think I didn't draw this one right, guys. We're going to need that to go up all the way to 4. Let's try that one again. So if I draw from 2 up to the line, yeah, that's at 4, not 3. Let's go fix that one. Okay, you were probably thinking that, and you didn't say anything. You're so nice. Okay, so Santa's Wonderland is an extravagant holiday light display that is open from early November through January each year. The entry fee is $15 per vehicle for up to 5 people, with an additional $150 per person over 5. Let's write a piecewise function for this. So f of x equals big bracket. All right. So first, it's $15 per vehicle for up to 5 people. So we're going to say for values from 0 up to 5 people. but they want 5 to be included. So in this little equation editor, I'm not in the text box, I'm in equation. I can go grab my less than or equal function. Okay, good. Next, the entry fee is $1.50 for each person over 5. So it's 15 plus 150 for x minus 5. This is that explicit equation we were used to writing in Math 1. Begins with 15 adding 1.5 for every 1 to the 1 before 5. Okay, now we need to write the domain for that, and that's for people over 5. So for x values greater than 5. And there's our piecewise function. So there's two parts to the piecewise. There's not just the actual equation part or the function part, there's the domain piece that goes with it. So you have to say from where to where is this happening and from where to where is this happening. All right, now we're on greatest integer functions again. It's asking for f of 0.35. Remember that they want the greatest integer to the left on the number line, the least greater than or equal to that number. So picture a number line at 0.35. What's that integer that it's closest to? And I'm going to say f of 0.35 is equal to 0. What is f of negative 5.2? Remember on the negatives on the number line, it's a little bit trickier. Negative 5.2 is equal to negative 6. That's the closest integer that's less than or greater or equal to. F of 10 is easy. It's just equal to 10. When you're given an exact integer, it's just equal to that integer. F of negative 0.5, closest thing to that negative 0.5 going left on the number line would be negative 1. And then finally, express f of x equals absolute value of x as a piecewise function. And we already looked at this earlier. Picture that V graph. And that's the graph of negative x first. It's going down. And then it's the graph of positive x next going up. Let's write that. Negative x and positive x. And it goes from negative infinity up to 0. And then it goes from 0 to infinity. A certain calling card gives the following rate to call Malaysia. There's a connection fee of 39 cents, which allows you to connect for up to but not including 1 minute. For each additional minute or part of the minute, there's a 24-cent charge. For example, 1 minute up to but not including 2 minutes costs 63 cents. This fare is only valid for up to but not including 40 minutes. Express the information as a function where f of x equals the amount of money charged and x represents the number of minutes. So this would be a good example of when we use the greatest integer function. So we're going to say it's 39 cents plus the 24-cent charge times the greatest integer. Let's go see if we have that in our symbols. Maybe we could use that to symbolize it. So what that means is whatever x is, we are going to plug in the x there and then take the greatest integer from that number. But so what's the domain of this function? If we're talking about calls, we're talking about number of minutes, Well, this rate is valid from 0 to 40 minutes. So we're going to say from 0 to 40 minutes would be my domain. So what's the range for that, or the price? Well, the cheapest price, the minimum price we could have is 39 cents, just as the flat number. And then what if we use the max of 40 minutes? So we're plugging in a 40 here. So if you do 40 times 0.24, doing that on my calculator right now, I get, 40 times 0.24 is 9.6 plus 0.39. Okay, so the minimum price that it could be, the maximum price it could be is our range, and the number of minutes could be 0 to 40 minutes. That's our domain. What is f of 2.5? Now it wants us to actually plug in to that greatest integer function. Now, if 2.5 is what I'm plugging in, what is the greatest integer of 2.5? We're just going to plug in 2, the number that's less than or equal to that integer, the closest integer. So now we're going to go 0.39 plus 0.48. Our final answer for f of 2.5 equals 0.87. Is this function a one-to-one? This function is not. Oops, let's go to text box. Because for many x values, there will be same y values. Okay, so it's not a one-to-one function. All right, finally, use this graph to answer the following questions. Is this graph a one-to-one function? If I draw a cross right here at y equals 1, it touches twice, doing the horizontal line test. So I would say, no, this is not a one-to-one function because at y equals 1, it fails the horizontal line test. It touches twice. Right there. What is the range of this function? It goes from -2 up to 2, but those values are not included. So let's write from -2 to 2, not included. And if I look up at the top of this graph, there's this whole other part of the graph at y equals 4. So that's part of my domain. So from -2 to 2, not included, and y equals 4. What is f of -1 and what is f of 3? All right, f of 3, 1, 2, 3, look up at my function, is just 4. And f of -1, go back 1 and look up. Now here's our area of interest. We've got an open dot one or a closed dot section. Which one is our answer? F of -1 is just equal to 1. And we're done.